You are about to learn how to solve a velocity time graph typical question. Stay tuned. Now let's look at this question and see how we'll go about it. A car runs at a constant speed of 15 meters per second for 300 seconds and then accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. This speed is maintained for 300 seconds before the car is brought to rest with uniform deceleration in 30 seconds. Draw a velocity time graph. Draw a velocity time graph. That's not all. To represent the journey described above. Then from the graph, we are equally asked to find first this acceleration, why the velocity changes from 15 meters per second to 25 meters per second. And next, the total distance traveled in the time described. And thirdly, the average speed over the time. Now, let's get started with this question. Let's get started. Sorry about that. So if we are to solve this problem, the first thing that we need to do is solution is to draw this graph, because since we're talking about a velocity time graph, obviously we should be able to draw the graph, because the graph will give us more info or give us a clearer picture of what we are trying to achieve. So let's go ahead and draw the graph with the information that we are given. So the car runs at a constant speed of 15 meters per second for 300 seconds. Remember, in a velocity time graph, it looks something like this. Don't mind my drawing. It's supposed to be something like this. Okay? Where this vertical side is representing the velocity, and this horizontal side is representing the time. The time in seconds. And the velocity here is in meter per seconds. Okay. So with that in mind, we go ahead and try to, put what the questions that we are given, put it in graphical way. So a car runs at a constant speed of 15 meters per second at first. So that means the initial speed that this question tells us that the car is running on is 15 meters per second. So we can try and denote that. Since I'm not using a ruler, I can use this to represent my 15 meter. Let this be my 15 meters per second. So if I move this way, let's say this is 15 meters, and this is the space of 300 seconds. So remember that here is always the initial. Here is 0. So that means I want to denote from here to here to be my 300. If I do that, then here is going to be 300. Here is going to be 300. Then from here to here is going to be my 15 meters per second. So we go forward. Then the car runs at a constant speed of 15 meters per second for 300 seconds. We've just represented that here. So here representing the time that the car ran for 15 with an average speed of 15 meters per second. And then accelerates uniformly. So that means acceleration means it moved upward, right? Good. So look at how we're going to represent that. It accelerates uniformly to a speed of 25 meters per second over a period of 20 seconds. So what I'm going to do, I'm going to move this upward, something like that, because it accelerates. And I want to use here to be my 25 meters per second that it accelerated. Just to be clear, it means just dot, 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 dot. So this is a freehand sketch, so it's not so accurate, but you get the point, okay? So once we've done that, we now check the time. So the car accelerates with a speed of 25 meters per second over a period of 20 seconds. Remember from here, originally, from here to here is 300 seconds. So that means the period of the acceleration is going to be from here to here. The time taken will be what? From the question, they said it took 20 seconds. But we can't write 20 seconds because that will mess up the graph. What we would rather do is, since we stopped at 300 seconds here, add 20 to 300 seconds is going to give us what? 320 seconds. Okay? So we achieved the acceleration. We move forward. I'm reading the question from my book that I have here. Then there's a full stop. Then we go, this speed is maintained for 300 seconds. So that means there's a maintenance of the speed for 300 seconds. Let's say that from here to here is the 300 seconds again that the speed was maintained. Let me join this. Let me say that from here to here is the 300 seconds. Now, of course, we're not going to write 300 seconds here, right? We're going to add 300 to this word, 320. That's how it's done. If we write 300 seconds here, it will mess up the graph. It will mess it up because the numbers are not aligned. The purpose of a graph is for it to be aligned. So 300 plus 320 is going to give us what? 620. So that is what? The speed, how long the speed was maintained. Then, before the car is brought to rest with uniform deceleration in what? 30 seconds. In 30 seconds. So that means the car decelerated and came to rest. Decelerated and let's say it came to rest here. And the period was 30 seconds. And I can't write 30 here. Nope, that is wrong. I'll just add 30 to 620. And it will give me what? 650. So once I've done that, I can now what? Go ahead and solve this problem because I've represented it on a graph. So for clarity purpose, you can use alphabets to denote. Let's see, here will be your A, here can be your B, here can be your C, D, E, here can be your F, and here can be your G, and here can be your H. Whatever alphabet that suits you, you can go on and use that. So with that in mind, we've drawn the velocity time graph. Yeah, my own is not so accurate, but you get the idea. This is how it's done, okay? So the next thing to do is to try and solve this question. With that in mind, let's go and solve the question. The first question says we should represent the equation on a velocity time graph, and we've done that. The second question now is that we should find the acceleration. Why the velocity changes from what? 15 meters per second to what? 25 meters per second. And as you know, acceleration is equals to what? Change in velocity. Let me use the delta to represent the change in velocity all over what? Change in what? Time. Okay? So if you go back to our graph now and calculate the period, go back to our graph and calculate the period that the car accelerated. You see, it's from this B to C. That is when it what? Accelerated. Okay? So if we know that, what we're going to do is just what? Find the difference. What is the change? The initial was 15, then he accelerated to what? 25, right? Good. So that means, and the time it took is from 300 to 320. So with that in mind, we just come here. What is the change in velocity? Change in velocity is just the final velocity, which is one it attained, which is 25. 25 minus the initial, which is 15. All over what? The change in time is actually 320 minus what? 300. If we do that, If you subtract that, what you're going to get is 25 minus 15 is going to give us 10. And 320 minus 300 will give us what? 20. If we solve that, we're going to have 1 over 2 or 0.5 meter per second square. Square because we're talking about acceleration. So we have answered the second question. I hope you understood what we did here. If you don't understand, please leave a comment. I will attend to you. Then we'll go to the second question. The second question from my book here is the total distance traveled in the time described. Now, this one is very, very interesting. Because if you look at this graph, the total distance, we know that the whole journey lasted for 650 seconds. That is the amount of time. So now, how do we find the total distance traveled? Well, it turns out that the total distance traveled, when you're talking about the velocity time graph, is equal to the what? The area of the shape that is formed in the velocity time graph. Yes, the area of the shape. So we can say that it's going to be the area of A, B, C, D, E, F, G, H. And if you look closely, just closely at this drawing now, this graph, you see that the first part here looks like a rectangle. The second part here looks like a trapezium. The third part here is equally a rectangle. You see what is a rectangle. And the last part here is going to be what? A triangle. So we're going to find their what? Individual area, then sum it up. Once we sum it up, that is the total distance. So let's go. So the total distance, let's go back to this one first. So is the area of this shape. This is a rectangle. Now what is the length of this? Because the area of a rectangle is length times what? Width, right? The length here is the distance from here to here. That is 0 to 300, and that is 300, right? So 300 times what is the width here? It's 15 because here is 0 to 5. So let's go down. So the total distance is equals to what? The area of a rectangle first. The area of a rectangle, which is equals to what? Length times width, which is 300 that we established multiplied by 15. Let's keep that aside. Let's go back to the question and let's go back to the graph rather and continue. So you see that the second shape here is a trapezium, and a trapezium, the formula for finding the area of a trapezium is what? 1 over 2 multiplied by the what? The length of the top and the length of the top plus the length of the bottom multiplied by what? The height. And the height turns out to be this. So what is the length here? Is the distance from here to here, here to here, and that is what? 15 for the top. For the down is what? 25. So add these two together. Then what is the height? The height is actually either you take this or you take this. And that is the difference between 320 and 300 down here. So we're going to have the area of a trapezium, which is equal to 1 over 2 bracket A plus B times H. A plus B denotes the height on top and down, which is going to be what? 1 over 2 times our A is 15, our B is what? 25. Then multiply by the height, which is what? 320 minus 300, and that's going to give us what? 20. Now, let's go to the third one. I want us to, let's rush this and go back to it. Let's go back to the graph. Then the third shape here, we can say that this is a square. Do you know why? Because square, that means, if it's a square, that means the length of the whole side will be equal. But that's not the case. Remember, from here, the top here to the down here is what? 25 here. And the down here and down here is the difference between 620 minus 320, and that is what? 300. So that means this is a rectangle, okay? So it's still a rectangle. So going forward here, we're going to have area of another rectangle, which is going to give us the length times width, which is equal to what? 300 times what? 25. Then lastly, let's go to the last part, which is what? The triangle here. So what is the area of a triangle? The area of a triangle is 1/2 base times height. The base is the difference between 650 and 620, which is 30. That is the base. Then the height is what? The distance between this D and F here. The distance is what? 25. So going forward, let's go forward. So the last is what? The last is area of what? A triangle. And that is equal to what? 1/2 times base times height. The base is what? Which is same thing as 1/2 times what? 30 times what? 25. Yes, so since we've gotten these now, let's go ahead and multiply all of them together and now find the total everything together. So for the first part, we have 300 multiply what? 15. Let's go and analyze that. So 300 times 15 is going to give us 4,500. So for this, we are going to have 4,500 as the what? The area. Let me write it down. Sorry. Let me write that down. So for the first one, you have 4,500 plus the second one. The second one is the area of a trapezium, and it's same thing as first of all, you add 15 plus 25, 15 plus 25, which is 40, then multiply it to the height, which is 20, then divide it by 2, which is going to give us what? Still 40. So go forward, add it to 40 here. That being said, okay. I think we made a mistake. Let's go back to that second part. Area of a trapezium. This is going to be 15. Sorry. It's supposed to be 15 plus 25, which is 40. Then multiply 20. That is 800. Yeah, I thought sorry about that. Then divided by 2. That's going to give us 400. So it's 400 instead of 40. So let's write 400 here. Then plus, go to the next shape. The next shape is a rectangle also. So it's length times width. So just do 300. I'm doing it here. 300 times 25. And that's going to give you 7,500. 7,500. Then lastly, the last is the area of a triangle, which is 1/2 base times height. Just multiply 30 times 25, then divide the answer by 2. You're going to have 375. So 375. Okay. 375. Okay. So let's add everything together. I hope you're following. Let's add everything together. 4,500 plus 400 plus 7,500 plus 375. That's going to give us 375, my bad. That's going to give us 12,775. And since it's talking about distance, the unit will be in what? Meter. See, we did it. So the third and the last question said we should find the average speed over the time described. Now remember that the time described is same thing as what? The total time it took for the whole journey to happen. And that is just equal to what? 650 seconds. So let's go and find the answer to the third question. So the average speed will now be equals to what? The distance, the total distance, all over the time it took. And we know the total distance already, don't we? Oh yes, we found it together. So the total distance is 12,775. Then divided by the total time, which is 650. So if you do that quickly, divided by 650, you're going to have what? That the average speed is equal to what? 19.65 meter per second. Yay! We did it together. Yes. So from this, I know that you must have understood, or if not understood, if you go through this video over and over, you understand the step-by-step that we took to answering this question. If you have any question, please leave it in the comment section and I will attend to you. Thank you. Bye.